In this video, we will talk about some application examples involving the FTC Part 2. So in the first example, it says that the rate of change of the number of people in Disneyland t hours after it opens at 7 a.m. is f of t equals this function here. And the units are in people per hour. And this model works for t being greater than or equal to 2. In part A, we want to calculate the integral from 4 to 12 of our function and round our answer to 3 decimal places. Okay, so we want to compute an integral. So we need this integral from 4 to 12 of our function. And seeing that 10,000, this constant, is multiplying the function, let's pull that to the front. So let's move that 10,000 to the front. And then I'll have the 1 over t plus 3 times 1 over t minus 1/6. And we can distribute all of that. Distributing that, we'll get 1 over t squared. And then 3 times 1 over t would be 3 over t. And then 1 over t times negative 1/6 would be minus 1 over 6t. And then the 3 times the negative 1/6 would be minus 1/2 dt. Okay, so simplifying this a bit, we get 10,000 integral from 4 to 12. Let's zoom in a little bit. Whoops, sorry, that's a little bit too much. Integral from 4 to 12. 1 over t squared, we can rewrite that as t to the negative 2. And then with the 3 over t and the minus 1 over 6t, we can get a common denominator if we multiply this first fraction top and bottom by 6. So if I multiply that by 6 over 6, we'll end up with 18 over 6t. So that subtracted by 1 over 6t will give us plus 17 over 6t, and then minus 1/2 dt. And now we're ready to take this antiderivative. So we have 10,000 in front times this, we do reverse power rule. So I add 1 to the exponent, and I get t to the negative 1. And then I divide by that new power. So divide by negative 1. With 17 over 6t, let's keep in mind that that's the same thing as 17 over 6, the constant, multiplying 1 over t. Because we know what the antiderivative 1 over t is. That's going to be ln of absolute value of t. So this will give us, we'll have a 17 over 6 in front of that ln. 17 over 6 times ln, absolute value of t. And then finally the antiderivative of minus 1/2. That's going to be minus 1/2 t. Okay, and now I put my vertical line to indicate I need to plug in 12 and I need to plug in 4. So let's plug in those values. So we get 10,000 all in front. And first let's plug 12 into this thing. So we plug 12 into this, we will end up with, so if we rewrite this term, t to the negative 1, if I bring it to the denominator, this is negative 1 over t. So if we plug 12 into that, we'll get negative 1/12. The next term will get plus 17 over 6 ln absolute value of 12. But the absolute value of 12 is just 12, so I can get rid of that absolute value. And then 12 to the next term, we'll get minus 12 over 2. So that's what we get if we plug in 12. Okay, so I'm going to put a big parentheses around all of that. And then if you plug 4 into this, what will we get? So we have to do a subtraction, subtract, and then what we get when we plug in 4. So into the first term, we'll get negative 1/4. Next term, we'll get plus 17 over 6 ln, but the absolute value of 4 is just 4, so I don't need the absolute value. It's ln 4, and then the last term, we'll get minus 4 over 2. Close that parentheses, and then close this bracket. Remember, 10,000 is multiplying all of this. So from here, we can plug this into a calculator. Up to this point, we were able to simplify everything, but the question says, let's round this to 3 decimal places. And in questions where I ask you to round something that involve antiderivatives, typically I'll ask you to do the antiderivative and plug in the numbers without a calculator. But then after you do that, you can use a calculator to simplify what you get. So plugging this in, this will be approximately negative 0.985. And there are going to be units for this. But before I write down the units, I actually want to look at the next part of the question. Because the next part of the question will help us remember, well, what are the units? How do we think about what the units are for something like this? So part B asks us to interpret your answer from A. Okay, so we need to interpret our answer from part A. So the key for this is what we did in this problem is we did an integral from A to B of a rate of change function. It was the rate of change of the number of people in Disneyland. So it was the rate of change, and it was dt. The function was with respect to time. And we've talked about what this integral represents before. The integral of rate of change, dt, represents the net change. The net change in the original function from t equals a to t equals b, from t equals a to t equals b. Okay, so let's highlight this. So this is a key result about integrals of rates of change and what they represent. So with that said, the answer that we got in part A, the answer in A represents a net change. I'm going to say it represents the change in, and what was our function? So our function before we took the rate of change of it was the change. So our function was the number, I'm going to put this hashtag for number, the number of people in Disneyland. From a certain time to a certain time. It was from t equals 4. And remember, the t value represented how many hours after the park opens. So the question said that Disneyland opens at 7 a.m. and t is the number of hours after it opens at 7 a.m. So if t is 4, that means 4 hours after 7 a.m. So 4 hours after 7 a.m. would be 11 a.m. So from that time to t equals 12 hours after it opens at 7 a.m. would be 7 p.m. Okay, so the answer in part A represents the change in the number of people. So those are going to be the units for that answer. It's just going to be people. Okay, but let's finish writing the answer to part B. So the answer in A represents the change in the number of people in Disneyland from 11 a.m. to 7 p.m. So what does this specific number mean? Minus 7205 point something something something. So in net, what that answer means, the fact that it was a negative answer, it means that there are about 7,206, if I round it to the nearest integer, fewer people in Disneyland at 7 p.m. than at 11 a.m. So that's what the fact that our answer ended up being negative tells us. That overall, the number of people in Disneyland has gone down by about 7,206. Alright, so that is our answer for part B, the interpretation. So let's look at another example. So example 6 this time. So a company projects that its marginal cost for producing X units of a new item in a week is given by this function. C prime of X equals this thing, $1,000 per item. Given the fixed costs are $25,000, part A is asking, what is the total cost of selling 40 items in a week and round our answer to 3 decimal places. So what I want you to do first is pause the video for about 45 seconds, maybe a minute, and just think about, based off of this question, what is the total cost of selling 40 items in a week? What is the question ultimately asking us to do? Like, is it asking us to take the derivative and plug some number into the derivative? Like, what is it ultimately asking us to do? 4, 3, 2, 1, pause the video. Pause it for 45 seconds and see if you can determine, well, what is the question asking us to do? Alright, so hopefully you've done that. Hopefully you paused it for about 45 seconds to really think about that. This time when you pause these videos and think about these questions that I prompt you with is really valuable because you're going to be engaging with these same things as you do assignments. Okay, so once the total cost, that's talking about the function c. C is the cost function. So it's going to ask us to find something related to c, the cost of selling 40 items. Well, the number of items is x. So it wants us to find a c of 40. So probably we're going to have to figure out the cost function by finding an antiderivative and then plug 40 into it at some point. Okay, so before we proceed with that, let's keep in mind that the question tells us the fixed costs. So the fixed costs are $25,000. So the fixed costs have to do with, well, what is the cost of selling no items? What is c of 0? So it might be really tempting to say, wait, c of 0 is 25,000. But that's not quite right because I have to think about units. And the units in this question say that our marginal cost is measured in $1,000 per item. So $1,000 per item. So something like, even though the fixed costs are 25,000, in terms of my function, we would say c of 0 is 25 because the units are in thousands. So when I write 25 here, it does mean 25,000. All right, so let's keep going. We are going to need to find an antiderivative of c prime. So we could do this either with an indefinite integral or a definite integral. So I want to, for practice, do it with a definite integral. So if I take a definite integral of my function, cube root of 5x plus 85x over the square root of 30 plus 4x squared dx. One of the values that we're interested in is what's going on at 40. And the other value we're giving information about is what happens at x equals 0. So I'm going to integrate this function from 0 to 40. So remember that this whole thing right here is the derivative of c. It's c prime of x. Okay, so FTC part 2 tells me that this integral is going to be equal to, the antiderivative of c prime, which is c of x. But plug in the top number, plug in 40, and then minus what you get when you plug in the bottom number. So this is what we'd get from applying FTC part 2. And we know what c of 0 is. We know c of 0 is 25. So if I'm trying to find c of 40, so our goal is we want to find this. We want to get this ultimately. Our strategy is going to be we're going to isolate for c of 40. We're going to figure out what this integral is. And we know what c of 0 is. So at the end, I'm just going to add this 25 to the left-hand side. And that'll give me c of 40. Okay, so now we need to figure out this integral. So for this integral, I want you to pause the video this time for about 4 minutes to try the integral. So 4, 3, 2, 1, pause the video. Pause the video for about 4 minutes to try to work out this integral. That may not be enough time to finish the whole integral, but hopefully to start to think about, well, what are the key ideas? How do I begin? And how do I proceed from there? All right, so hopefully you did that. Hopefully you paused it for about 4 minutes to really think about this and try this integral for a bit. So one thing that will help is splitting it up into 2 pieces. So this we can split up as the integral from 0 to 40 cube root of 5x. And actually one thing that's going to help there is I can rewrite this term. So cube root is the same thing as a 1/3 power. So 5x to the 1/3. And then I can use an exponent property to say that, oh, this is 5 to the 1/3 times x to the 1/3. So let's go ahead and do that. That'll give me 5 to the 1/3 times x to the 1/3. And that's going to make it easier to do the antiderivative of, because 5 to the 1/3 is just a constant, so that'll just stay there. And x to the 1/3 is an easy antiderivative to do. Okay, so that's my first integral. Second one is going to be 0 to 40 of 85x over that square root, over the square root of 30 plus 4x squared dx. Okay, so let's work out this first one, because this one's going to be the easier one to do. Let's move that 5 to the 1/3 to the front. That's just cube root of 5. And then the antiderivative of x to the 1/3, reverse power rule, we'll add 1 to the power, get x to the 4/3. And then I divide by this power. Dividing by 4/3 is the same thing as multiplying by the reciprocal. And the reciprocal is 3/4. Alright, so that is that antiderivative. And then I need to plug in 40. And I need to plug in 0. Okay, so now let's go ahead and finish that off. If we plug in 40 into this, we are going to get, let's see, let me put the 3 in front, and then cube root of 5. And then plugging in 40, we'll have 40 to the 4/3 over 4. That's what you get if you plug in 40. And if you plug 0 into this, 0 to the 4/3 power is just 0. So we'll get minus, and plugging in 0, we'll just get 0. Okay, and this is something we'll be able to work out with a calculator, but we have done this first integral. That one wasn't too bad. Let's think about this second integral. So for the second integral, we can do a u substitution. So we can let u be equal to the inside of the square root, 30 plus 4x squared. And I know this is going to work, because if I take the derivative of this, I'll end up with an x term, 8x technically. So du is 8x. I got to make sure I write that dx next to it. And I see a constant multiple of that in the numerator. I see 85x. That's how I know it's going to work. Okay, and then if I isolate for dx, we get du over 8x equals dx. Okay, so ultimately we're going to start to sub this in, but this is a u sub question where we have these limits of integration. So let's handle this by changing those limits of integration. Okay, so we need to do this for both of them. So one of them is x equals 0, the other one is x equals 40. So when we do a u sub, one of the ways that we can handle these limits is by converting them and seeing what they are as u values. So if I take x equals 0 and I plug it into my substitution, we will get u equals 30 plus 4 times 0 squared. And that's just 30, so not bad. If I plug 40 in, we'll get u equals 30 plus 4 times 40 squared. And if we work this out, this ends up being 6,430. Alright, so we are ready to now substitute in to our integral and change those limits of integration. Okay, so if we do this, we end up with equals, and we get an integral. The bottom limit has become 30, and the upper one has become 6,430. Okay, we get 85x over square root of u, and then dx. We saw dx was du over 8x. Okay, so it's already starting to look a lot simpler. So we have the integral from 30 to 6,430. The 85 over 8, we can pull to the front because it's a constant. The x's cancel. The x's cancel, that's the nice part about it. And then the square root of u, we can move to the numerator and rewrite it as a fractional power. And it'll become u to the negative 1/2. And from here, this is an easy antiderivative. We end up with 85 over 8. Now this is going to be reverse power rule. So I add 1 to the power and I get u to the 1/2. And I divide by that new power. So if I were to divide by that new power, divide by that 1/2, that's the same thing as multiplying by the reciprocal. So u to the 1/2 divided by 1/2 is the same thing as u to the 1/2 times the reciprocal, which is 2. I'm going to go straight to that. I'm going to multiply this by 2. Okay, and now vertical line to indicate I need to plug in 6,430 and 30. Okay, so we are almost ready here. Alright, so 85 over 8 times 2 will cancel a little bit, and I'll get 85 over 4. And when I have a constant like this multiplying everything, I can just keep it factored out of what I plug in. So now when I plug in, first I'm going to plug in 6,430. So I'll get 6,430 to the 1/2 power, which is the same thing as the square root of 6,430. And then minus what I get when I plug in 30, so that'll give me square root of 30. All right, so we have worked out our second, if I zoom out a little bit here, we have worked out now what this second integral is. I'll just have to plug this into a calculator. And earlier we had worked out what this first integral was, this 3 cube root of 5 type term. So let's start to write all of that together. All right, so thus, we wanted to figure out, let me scroll that up a little bit so I can see it. Okay, I gotta zoom out a little bit. Ultimately, remember, we were trying to isolate the C of 40. So now we know that C of 40 is going to be equal to this integral that I had on the left, which we split up into 2 pieces. And one of those pieces was 3 times the cube root of 5 times 40 to the 4th, not 3/4, 4/3. 4/3 power over 4, and then plus the second integral, which we just got, was 85 over 4 times the square root of 6,430 minus the square root of 30. Okay, and then there's also this C of 0 term, which was 25, which I'll have to move to the other side. I'll have to add that. So we'll have to add that 25. But just remember, this was C of 0. This was C of 0 here. This was C of 0. Let me just highlight everything. This was C of 40. And in a different color, we had this integral, which ended up being all of this. All right, so now let's just plug this into a calculator. Okay, so I'm zooming in a bit here, so it's easier to write. This ends up being approximately equal to 1788, and it asked me to round it to 3 decimal places, which end up being 030. And what were the units of our function? The units of our function were, so now this is the cost function, and the units were $1,000. And that would be our answer. So $1788.030 thousand dollars. It looks a little bit weird if we keep our units like that. If we were to convert this either to dollars, so if we were to convert this to dollars, this ends up being about $1,788,030. Or in other words, it's about $1.7 million. Alrighty, so that is our answer there to part A. And that's the cost of 40 items. Alright, one more part to this example, part B, which asks if the company sells all 40 items in a week for $500,000 each. It's a very pricey item here that we're talking about. What is their weekly profit? So remember that profit is equal to the revenue minus the cost. And what we got in part A was the cost of 40 items. Okay, so what's left for us to figure out to determine the profit is the revenue. So I'm going to put capital P for profit. So for the revenue, the way we figure that out is we multiply the price times the quantity when they're selling these items for a fixed price like they are here. So they're selling them for $500 each. So the price is $500,000. And if I think about units even, this is $500,000 per item. And then we multiply that by the quantity. And what's the quantity? They're selling 40 items, so times 40 items. Alrighty, so I just shifted that over a little bit so it aligns better. And then minus the cost that we just got. So minus $1,788,030. This is in dollars. It's a little bit weird to write the dollars after this, but nonetheless I can. Okay, so plugging this into a calculator, this ends up being, notice that in terms of the units, this item on the denominator cancels with this item on the numerator. So overall, we're subtracting a dollar quantity from a dollar quantity. So profit is going to be in dollars, which makes sense. So in dollars, it's 211,970. So a little over $200,000 would be their weekly profit. And that's our answer. So in terms of our goals for the section, we finished our last goal, doing some application examples. So we saw some more challenging examples in this video. Application examples can be trickier to handle because they're word problems that we have to convert to math expressions, but we are building more and more experience doing that. And then the actual integrals themselves can be challenging. But as we get more practice handling them, we'll get better and better at it.